Welcome, guys. The last video I created, I made a video where some columns and beams failed on a structure that I'm designing. But so the main reason why I'm creating this is to show you guys the stage where I got. So I was able to let me minimize this and open. So I was able to design it as you can see from this as you can see from this page. See that everything is on green. I was able to design it to this point. So you see, we have the column base and the columns are they are on greens. So if you see very well, you will see that I actually increased this column to 450 by 450. The reason is that we have a cantilever. We have a cantilever. Let me just raise it up so that it will be very well. So the reason is that we have a cantilever by the two side. So on this angle, so this column, I increase this column here so that you'll be able to carry it. That's why it's on green. So for you to be showing green like this, it shows that to be able to like bear the load on it. So it happens on both sides because it's a block of flats of 2 units. Whatever that is on the left hand side is on the right hand side. So that is it. So we're able to achieve this like this, and we ended up creating the analysis and bringing it out to AutoCAD. So you see, this is the design. Look at the structural design here. So which we are able to like create the foundation layer. So in this foundation layer, this will actually help you to know on how to set out and excavate your trenches. So this is the part foundation. That column that I show you guys that is bigger, you see it here. See, so foundation column type 28, which is 450 by 450 by size. So the column base is actually by 1500, which is the part foundation, which you have to like put your reinforcement 1500 by 1600. The depth is 300. So we have it here. We also have it here. We also have it here. So if you follow all these specifications, this building will last as much longer as anything, more than anything. You see, this is the trenches. This is the trenches, the excavation, you're excavating 1.2 meter and 200 depth concreting. Like the 200 is supposed to be 250 because we have a blinding. Look at it, you have a blinding on it. So you're excavating 1.450 meter. So you see, we come to this point, we have the column base details, which we have the reinforcements. So the number of reinforcements 8y 16 250 spacing, you see, by 1006 excavation, which is that 450 column. So we still have the general beam arrangements, have the general beam arrangements. We have the details of the general beam arrangement. This is the detail. So everything here is being confirmed by my the structural engineer. So with everything here, this building can last as much longer as it is. So here we have the slab details, which you can see the alignment of the reinforcement, the way it's been, and details the number of reinforcement. So here we still have the roof beam uh, the roof beam arrangement. So on this roof beam arrangement, we have the details. So we have the details. So that of staircase, we still have staircase. See, everything is here. We have a staircase design. So we also have the column design. So this is the column design and the column details. You see. So anyone on this downside means on the ground floor. Anyone on this upside means on the up floor. Anyone that did not have any column on the top floor, it means that it terminates on the ground floor. So we have so number of columns that actually terminate of this particular design that terminates on this ground floor that did not continue on the first floor. You see how it is? So we have the out of that 450 column, this is it. It ended on ground floor, but it did not continue on the top floor. So that is it. So this is the details you see out of 450 column. I'm using it because it's the bigger. So I brought the details out. You see, it ended on the ground floor, which we have some column that actually continues to the top floor. Continues to the top floor. We have some that's from the top floor to the roof beam. So you see, we have the roof beam details right here. So This particular structure was actually sent to me by an architect. So architect designed it and he sent it to me for me to create the structural design of it, the mechanical and the electrical design. So I was able to like create it. So coming to this point, you will see that we have the electrical design also, which we created yesterday. We created this design yesterday. You see the notes. So everything here was actually telling you the right thing to do. So the right way to follow, the right things to follow. So we have the legend here. Everything here, every symbols here indicates something. So we have the legends on this for this particular electrical design. So if coming to this point, you will see the way the wiring is from the bulb and everything. So you have the power lightning from the sorry, this one is part of the ground floor. This one is part of that of the first floor. You have the one of ground floor for power lightning switches and sockets. So we have the one of first floor here. So coming to this place, we have the earth termination details. We have the distribution for the lightning. We still have the distribution type capable distribution here. So coming to the mechanical side of it, we have the mechanical side of it, which we have the notes, the legend first. So every symbols here indicates something, and all of them appears on the drawing. So you have the height at which each fittings has been fixed. See the kitchen sink being fixed at 900 millimeter, which is 0.9 meter height from the ground level, water closet and everything. The mounting height is being listed here so that they won't make a mistake. So if you come into this way, you will see that we have the inlet water and the outlet water, which means the one of outlets is that of wastewater, which we have. Okay, let's use this place. We have this toilet here, is a ground floor. Have this toilet here and the WC for this point. So we have the wash hand basin here, which piloted the water to the chamber out here and take it down to the water 100 millimeter wastewater pipe. You can see direction. So and it's heading direct to the sockaway here. Heading direct to the sockaway here. So we have one of fresh water. This is overhead tank, which is pushing water in. From this place, water was directed inside. It's being directed inside, which linked to your shower and everything, your water system and everything. You see, this one was a discharge. It joined the discharge pipe. One of inlet actually comes to the um, tank that is using for flushing and everything. You see, it's been well designed and everything. Look at that of kitchen. So this kitchen sinks has been channeled down to this chamber, also channeled down to the uh, wastewater, which is the soccer waste side, the septic tank. So we still have that of the first floor, which we have everything. Everything. The that of fresh water is coming in from this pipe of green. So you see, it's coming in that of this pipe of green. The piping sizing and everything, 25 millimeter water supply pipe size. So, but that of discharge is bigger. You have one of 50 millimeter water wastewater pipe discharge. So everything is being detailed here. So coming to this place, we have the bathtub sizing and the everything. It's been the fitting details, which we have here. We have the pipe and everything, the mechanical fittings and everything. You see, that's what I'm basing uh, the height and everything is being shown here. So as a mechanical engineer, you'll be able to follow up this and give the your clients exactly what they need. This is the overhead tank, the toilet and everything. The way it's been designed. So you see, so that of the soccer way, this is the soccer way design. So but you don't have the architectural design. So we don't have the architectural design, but the architect actually creates the architectural design. So we work hand in hand, both architectural architect and a structural engineer. And although all those every aspect work hand in hand to achieve a greater goal in this engineering aspect of life. So in case you have a work like this, you should do well to give it to professionals. Don't carry no carry your work go give people wey be say in the next 5 years your building will fail or maybe you start seeing cracks or something. So if you actually follow everything and I details on this drawing, sorry, if you follow everything I detail in this drawing, you won't see any single crack on that particular building. Yeah. Don't use because of saving cost and risk your life. Instead, save your life first because that's the most important thing to do. So The next video I'm going to create a video maybe where I'm creating a new structural design, which I'm going to like detail it here live and also post it. So please do well to subscribe to my YouTube channel, which I'm going to put the link on my Facebook video. If you are new, you can actually subscribe to my YouTube channel and also like my videos. You can send it to your friends, you can send it to any of your engineer to confirm what I'm doing, or maybe if you have a work for me, you should contact me direct. So my number will be there. You can get my number from the YouTube channel, you can get my number from Facebook, which is the two major social media where I'll be dropping this video. So thank you.